All right, number 33. So which expression is equivalent to 16k to the ninth m7 over 4k to the third m to the 14th for all values of k and m where the expression is defined? So let's get a color out. So remember, we say normal numbers do normal math. Well, 16 divided by 4 is 4. All right, so I know our coefficients simplify to 4. Well, now I'm looking at my variables. I have k to the ninth over k to the third. And we always say, who's got more k's, top or bottom? Well, top has more. How many more? Well, nine. Oh, not nine, sorry. Six more, right? Because 9 minus 3 is 6. So now let's get our m's. Who's got more m's, top or bottom? Well, bottom has more by 7, right? Because really, k to the ninth means I have 9 k's. 3, 4, 5, 6, 7, 8, 9. And k to the third means I have 3 k's. Well, 3 on the bottom cancel out 3 in the top, and there are 6 left on top. All right. So our exponents have their own rules. Right. So when we're dividing, we just see which side has more, and then we subtract, figure out, well, how many more they have. So super simple, right? But normal numbers do normal math, right? And remember, our rules of exponents are on our formula chart, right? When we're dividing, we subtracted, right? M minus n. That's what we did. 9 minus 3 was 6, right? Well, 7 minus 14 was negative 7. But again, when our exponent is negative, that means we have got to flip it to the bottom. Right? I think it's easier just to talk about, all right, who has more and how many more. So pretty easy. All right. For quadratic function h of negative 3 halves equals 0, and h of 5 equals 0. What is a possible equation for h in factored form? Move the correct answer to each box. Not all answers will be used. So that last one I thought was not too difficult. I think this is one of the harder problems because we've talked about how to go from a factor, right? We've talked about how to go from a factor, one of these, all right, one of these, to a solution. All right, we got to work backwards now. Well, if our solution is positive 5, well, that means our factor should have been x minus 5, right? Because it's the opposite of our constant. So the opposite would be positive 5 over our coefficient. Well, our coefficient is 1. So 5 over 1 is 5. Okay, so that one was easy. But if it's negative 3 halves, I mean, all right, well, it's negative. So I know it's going to have to be plus, right? And then it's always our constant divided by our coefficient, right? So the opposite is negative 3 over 2. Well, that's what I want, negative 3 halves. So it should be 2x plus 3. So we drag and drop these down into these blanks, x minus 5 and 2x plus 3. And if we wanted to check it, let's see if we can plug that in our calculator. Oops, not a reference chart. So we our calculator. All right. And I go to y equals, and I type in 2x plus 3. Oops. 2x plus 3. And my other parenthesis was x minus 5, right? That's what we said our two factors should be. Well, if I graph those, well, yeah, it hit. It's at positive 5. And this is between negative 1 and negative 2. So that's negative 1 half, which is negative 3 halves, right? Negative 1 and 1 half. Sorry, negative 1.5. So yeah, that worked. So it's x minus 5 and 2x plus 3. However, that was a more challenging problem because we've never really seen one like this before, where they give us a solution, so we got to work backwards to find our factors. So we've gone from factors to solutions, but we did this the other day. We talked about it, so hopefully you remember. All right, a triangle has sides whose lengths and units represented by polynomials as shown, where x is a positive integer. Which expression represents the perimeter of the triangle in units? Well, for perimeter, we just add up our sides. All right. Well, we have variables and we have constants. Let's add up our variables first. So I got 3 halves plus 3 plus 2. All right, so let's see what that is. I go, all right. So 3 halves. Oops. All right, 3 halves is 3 divided by 2 plus 3 plus 2. And that's 6.5. All right, so we know how to turn a decimal into a fraction. We hit math, enter, enter. And so it should be 13 halves. Ooh, so then right away, I know, oh, whoops, strike through. I know it's not this one or this one. So now we got to add together our three constants. Okay, well, I got parenthesis 5 divided by 6 plus parenthesis 1 divided by 3. But since this is minus 1 6, I got a minus 1 divided by 6, which is 1. So it means it should be 1 on the end. So it's 13 halves x plus 1. That was pretty easy. We added our three variables together to get our variable term. Then we combined our three fractions together to get our constant term, right? Fractions are just numbers. We got a calculator. Worst comes to worst, we can just plug them in. So again, like that should have been an easy problem. We're not going to get flustered that it's a fraction. We got a calculator if we're not good with fractions. Not a big deal. All right, the total cost Y for X tickets to a concert includes a flat fee for processing and a cost per ticket. One customer purchased 4 tickets for a total cost of $160. Another customer purchased 8 tickets for a total cost of $300. Which linear equation represents the total cost in dollars Y for X tickets? So we talked about this problem in class before, and some of you were like, oh, I knew right away it wasn't A or B. I was like, oh yeah, how'd you know that? They said, well, it says there's a flat fee and a cost per ticket. Well, that means I need to have two different values. And I was like, man, that's super smart. All right. Some of us were like, oh, I didn't catch that. Well, that's okay. All right. But some of us were like, well, if 4 tickets cost $160, they said, well, 160 divided by 4 is 40. And they told me it was A. I go, yeah, but then is 300 divided by 8? Well, what's 300 divided by 8? And they're like, so let's see. 300 divided by 8. Well, oh, whoops. 300 divided by 8 is 37.5. So this is 37.5. Well, I can't just divide. They don't equal the same thing when I divide. So again, I should have known. Well, A and B aren't right because it's got to make both. This equation's got to make both things true. So then let's go. Let's clear this. Let's think about it. Well, let's figure out how much does each ticket cost, right? The difference between 4 tickets and 8 tickets, and the difference between 160 and 300. So let's see. Right? If we're trying to find cost per ticket, well, that means our cost should be on top and our tickets should be on the bottom. So let's figure out, well, what's the difference in our cost divided by the difference in our tickets? Well, 300 minus 160 is 140. And 8 minus 4 is 4. Well, 140 divided by 4 is 37.5. So that means not 37.5, sorry, is 35. So that means it's 35x plus 20. All right. Let's see. If I plug in our values for x, all right, so let's see. If we have 35 times 4 plus 20, oh yeah, that did equal 120. Let's see what it costs for 8 tickets. Well, 35 times 8 plus 20. Well, that equals 300. Well, it's supposed to be 300 for 8 tickets. So this equation makes both things true. So I could have done that. I could go, all right, well, if my X value is the number of tickets, right, I can just plug in my X numbers into my equations to see which one is true, right? If it says X tickets, well, that means I'm plugging in the number of tickets for X. All right, so if I plug in 4 times 40 is 160, but 8 times 40 is not 300. Right? So I could have done that. Or some of us are like, well, like I knew that these are just data points. So I could use my calculator, go to stat edit and typed in my table. I go, all right, stat edit. So four tickets, right? It says tickets are my X values. So my X values are 4 and 8, and four tickets cost 160, and eight tickets cost 300. So we have two X and Y values. So stat calc 4. Now you know, 35 is my A value, so 35x plus 20. 35x plus 20. Lots of different ways I could have gotten this problem. All right, so guess and check would have worked. Could have used my calculator, could have just subtracted them to find the cost of how much does each ticket cost, and there's only one that had that cost. Lots of different ways to do it. I couldn't just divide one of these, though. It's got to make both things true. Okay. All right, which expression is a factor of x squared plus 7x minus 30? All right, when we see factor, well, we got to do our x box. So we start with our x. All right, we'll check for a GCF. But I mean, if it's ever a 1, I know there's no GCF. So x squared times negative 30 is negative 30 x squared. My middle term goes on the bottom plus 7x. Well, if the top is ever negative, I know it's a negative and a positive. So my numbers need to be 10 apart. So what numbers multiply to equal negative 30 and add to equal positive 7? Well, it's a negative 3x and positive 10x. Negative 3 times 10 is negative 30. Negative 3 plus 10 is positive 7. So now we know, right? First term in the first box, last term in the last box. But now we split this middle term into these two pieces. All right. So our sides go in our two corners. It doesn't matter which one goes where. So I'm going to put negative 3x here, positive 10x here. Switch my color. So now x squared and 10x, their GCF is, oh, it didn't switch. Their GCF is x. So since this is minus, this is minus. Well, 3x and 30, their GCF is 3. So now side to side, GCF is x. This is plus, so it's plus. And then 10 and 30, their GCF is 10. So then which of our two factors are there? We have x minus 3 and x plus 10. So x minus 3 is the answer. That's one of our options. All right, so when we see factor, we go, oh, we do our X box, get our two factors. Sometimes they give us both. Well, then I just got to match them both. But if they only ask for one, I just got to figure out which one is there. All right, the graph of f of x equals x is transformed to create the graph of g of x equals 1/2 f of x plus 3. Complete the statement to compare the graphs of f and g. Choose the correct answer from each drop-down menu to complete the sentence. All right, so let's look at our all right, this is our transformation. Yeah, all right, well, if I multiply by a number, that's changing the slope of my line. And if it's less than 1, well, this makes it less steep, right? Our line gets a little flatter. And when we're adding or subtracting, well, that's moving our y-intercept. So this is going to shift our y-axis up 3. So let's look at what our options are. The graph of G is less steep. Well, yeah, because 1/2 is less than 1, so it makes it less steep. And the graph of F and has a y-intercept that is, well, instead of it being at 0, right, there's no number over here. Well, now it's at positive 3, so now it's greater than, right? Because 3 is greater than 0. So again, knowing, that's why we practice these transformations, because knowing, oh, multiplying changes the slope, adding or subtracting changes the y-intercept, that was a really super easy problem. All right. Line N is shown in the coordinate grid. The table of ordered pairs represents some points on line P. Which system of equations represents line N and line P? All right, well, this is a harder problem. We got to do a lot of steps on this problem. Well, the first thing I'm going to do is find the equation of this line on this graph. So, all right, got y equals. So my y-intercept is -2. So I node into -2. And I go up 1, 2, 3, and over 1. So 3 over 1 is 3. So it's 3x minus 2. All right, we're gonna remember that and write it down. 3x minus 2. Oh, but there's a problem. These are not written in slope-intercept form. So if we had y equals 3x minus 2, I got to convert it to standard form. So you'll notice in standard form, my x's and y's are on the left. So I got to move this 3x to the other side. Well, if it's positive 3x, when I flip it now, it's negative 3x plus y equals negative 2. But you'll notice our a value is always positive. So since it's negative, I got to multiply the entire equation by negative 1. So I get 3x minus y equals 2. Oh, so I see that here. Oh, it's not there. I see that here, and it's not there. So now I know it's either A or C, because I know the equation of the graph is 3x minus y equals 2. Well, now to check my other one, well, we got a calculator, right? Any table, we can just plug that in. All right. So we know how to go. I go to stat and then edit. I'm typing my numbers. Negative 1, 0, 1, 2. Then 6, 4, 2, 0. Stat, calc, 4. And it's negative 2x plus 4. So I'm going to write that down. Negative 2x plus 4. So y equals negative 2x plus 4. And some of you are like, well, I didn't need my calculator. I knew the y-intercept was positive 4 because that's where x is 0. And you're right, it is positive 4. And I just subtract, all right, our formula for slope is y minus y over x minus x. So 6 minus 4 was 2 over negative 1 minus 0 is negative 1. So my slope was negative 2. Well, that's what we got. Right? So I don't need my calculator. I can always use it though. But we know how to find the slope and the y-intercept from a table. Well, that's pretty easy. So again, now I know it's negative 2x plus 4. All right, but again, I need it to be in standard form. So I got to move my x to the opposite side. So if it's negative 2x, when I flip it, it's positive 2x plus y equals 4. So let's see. It should be 2x plus y equals 4. Well, that is A. A says 2x plus y equals 4. So A makes both true. So, I mean, that was a lot of work for this one problem, but we got it right? None of that work was difficult. It was a lot of work, but none of that work was very difficult. We should be able to find the slope and y-intercept from a table and from a graph relatively easy. Or worst comes to worst, like this. All right, but yeah, we're gonna go with A. A is correct. Moving on. All right, which function is equivalent to f of x equals 4x minus 3 squared plus 5? So I have to turn this vertex form into standard form. So to do, I got to do 4. So now I got x minus 3 times x minus 3 plus 5. Right? Because remember, x minus 3 squared is not just x squared minus 9. It means I have two x minus 3s. So again, my 4 stays on the outside. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So now I got to distribute my 4. 4x squared minus 12x plus 36 plus 5. Now I got to combine my like terms. 4x squared, negative 12 and negative 12 makes negative 24. 36 plus 5 is 41. So our answer is C. Okay. Well, okay, we've learned how to do that. 4x squared minus 24x plus 41. Good deal. We got it. Okay, so I had to double distribute, which we've been practicing, then distribute my 4, then add my constant. Okay. Oh, I forgot to take off my, gotta clear this before we move on. So oh, we got C. All right, 41. Which graph best represents the solution set to x plus 2y is greater than or equal to 2? Well, first off, I know if it's or equal to 10, it's got to be a solid line. So then right away, oh, it's not a dashed line. These two are obviously wrong. Okay. But to be able to read our inequality symbols, it's got to be in slope-intercept form. Well, this isn't. This is in standard form. So I got to move my x over. So it should be 2y is greater than or equal to negative x plus 2. So we divide by 2. Oops. So then it's y is greater than or equal to negative 1 half x plus 1. So let's look at our options. Now, if it's greater than, I know it's got to be shaded above our line. Well, this one's shaded above, but this one is shaded below. So then, oh, this one's definitely wrong. It's not shaded above. And some of you are like, yeah, but it was already shaded. It was already greater than. Why did I have to do that work? Right? It was already greater than right here. Why did we do this? So remember, the reason that our sign did not flip is because our y value is positive, right? If this would have been x minus 2y is greater than or equal to 2, when we move our x over, but then it's negative 2y. And when we divide by negative, well, then that's going to flip our symbol, right? So you're right. If I'm looking here and my y value is positive, well, then I know my symbol's not going to flip. I really don't need to do all this work because then the only difference between our two lines is one was shaded above and one was shaded below. But if our y value is negative, like it, and for this example, well, then that's going to flip our symbol. So now it's going to be shaded below. And since that's a lot to remember, I think it's easier just to convert it to slope-intercept form no matter what. Then we know we're going to get it right. But again, like knowing the or equal to is a solid line, great. And once I have it in slope-intercept form, greater than's above, there's only one that was a solid line and shaded above. All right, a system of linear equations is shown. Which statement about this system is true? All right, so we know there's either one solution, zero solutions, or no solutions. All right, so they have zero, they have no, they have infinite, and there's two different ones that are one. So we need to check. All right, so we're going to solve by elimination. So our first one's already set up, x is y is 10. So I got to move this over here. So now it's going to be negative 3x plus y equals negative 5. Okay. Well, if our top equation is 6x minus 2y equals 10, if our top one is positive 6, I need to make this bottom one negative 6. Well, it's already negative 3, so I'm going to multiply this whole equation by 2. So then my x is going to eliminate. Negative 6x plus 2y equals negative 10. And our original equation was 6x minus 2y equals 10. So let's see what happens. Well, my x's eliminate, but look, my y's also eliminate. So now all I've left is 0. Well, 10 minus 10 is 0. Well, 0 does equal 0. So if all my variables eliminate and my statement is true, well, that means there are infinitely many solutions, right? That means these two are the exact same line. If I change them, look, this one's in slope-intercept form. If I did the other one, all right, I'm going to change my color. And I move my x over. Now it's negative 2y equals negative 6x plus 10. And I divide both sides by negative 2. I get y. Negative 6 divided by negative 2 is 3x. Positive 10 divided by negative 2 is negative 5. Well, yeah, they have the same slope and the same y-intercept. So that is infinite solutions. They're the exact same line. All right, so if we're setting up and doing our elimination and they equal each other, if it's 0 equals 0, well, that's infinite. If it had been 0 equals 4, right? if our variables eliminate, but our numbers are different, well, that means there's no solution because that means they have different y-intercepts. They got the same slope, but different y-intercepts. Okay, so it's what we when we write down no, many, and one solution. For no, we put same slope. For infinite, we put same slope and same y-intercept. And for different, we say, I mean, for one solution means they got different slopes. So we could have checked it that way. Right, but that was a more difficult problem. All right. Company currently has 500 employees. The number of employees is expected to grow at a rate of 2% each year. Write an exponential. All right. So I know it's an exponential function to model the number of employees in the company Y after X years. Well, if it's an exponential function, that's because X is the exponent. So our initial value is 500. That means 500 goes outside our parentheses, right? And if we're growing up 2%, well, that's 2% more than 100%. So it's 102%, right? So if it's 102%, all right, for every percent it is growing, we add that to 100. So 102% is 1.02. So in parentheses is going to be, all right, 1.02. All right. And like this is kind of tricky as messing with this. If I hit parenthesis, it makes another open parenthesis. But if I hit this button right here, there's the arrow. I think it flips it. So now I know, all right, well, it's closed. And to do an exponent, right? This is our base, and we're raising to an exponent. Exponent x, right? It's exponential because the x is the exponent. This was the trickiest way I've ever seen this problem. Never before have we had to type one in before. Okay, so again, but we know that I think this one was hard because people didn't know exactly how to type stuff in. That's why I wanted to make sure we took the time to talk about it here. All right, but again, like we know, oh, initial value on the outside, right? Growth factor on the inside. X is the exponent. Okay. Again, since that I think that one counted as 2 points. All right, which relation best represents y as a function of x? So remember, we don't repeat our x's. I don't care why you broke up, don't repeat your x. So I got to look for the function where my x's don't repeat. Well, A, look, -2, -2 repeats. C, -4, -1, 2, and 6. All of my x's are different. That's our function, right? We don't function with our x. That's why we broke up. But I don't care why you broke up. Doesn't matter. You don't function with your x, all right? And if it's a graph, we check our vertical line test. Because look, this is where x is -2. Well, there are two different y values. So that means my x is repeating. Same thing here. Anytime it's stacked, then I know that is not, right? Because again, where x is -2, well, there's a solution here and a solution here. So again, our x repeats. So again, functions, you don't function with your x, so don't repeat them. All my x's are different. That's our function. All right, the function f of x equals -4x plus 8 represents the first of two equations in a system of linear equations. The second equation in the system has a different slope than the first equation. Which statement is true about the solution to the system of equations? All right, so let's see. So we know our three types of solutions are no, infinite, or one. Never is there two solutions. All right, but we've talked about, well, if they have a different slope, well, that means, right, when it's no solutions, it means they're parallel and they have the same slope. When it's infinite solutions, not only are they the same slope, they have the same y-intercept. The only time, if they have a different slope, that means they are going to intersect one time, right? Like our people who are running at different rates and they start at different times, well, they're going to cross at one point, so only one point. All right, what is the solution to the equation? 7w minus 2 parentheses w minus 9 equals 4 minus 8 parentheses w plus 2. Well, we can just solve this algebraically. All right, so I got to distribute on the left. So the 7w, so I got to distribute -2 times w is minus 2w, and -2 times minus 9 is positive 18. So now again, this 4 is not touching my parenthesis. I got to distribute this -8 times w is minus 8w, and -8 times 2 is minus 16. So now I need to simplify each side. So I combine my like terms. 7W minus 2W is 5W plus 18. And over here, I only have one variable part, minus 8W, but I have two constants, 4 minus 16. Well, negatives are ahead by 12. So now we've simplified both sides. So now I got to get my letters to the left. So if it's minus 8W over here, it's going to be plus 8W. And I got 13W. And I got to get all my numbers to the right. If it's plus 18 over here, I got to subtract 18. So it's minus 18. So that's negative 30. And we're trying to solve for W. So I divide by 13. And I get W equals negative 30 over 13. Well, that's right. So we could distribute, combine like terms. This is how we started our year. This is what we did. So we got D negative 13W, negative 30 over 13. All right, but look, we know that's the right answer. We've learned how to store numbers in our calculator. So if I wanted to just be a little lazy, I could go, all right, well, negative 30 divided by 13, and I want to store that for X, right? Whatever that number is. So now when I type in my equation, each side of my equation, they should equal the same number, right? And we can use X instead of W. So 7X minus 2 parenthesis X minus 9. And I get this weird number. Let's see, if I type in 4 minus 8 parenthesis X plus 2, I get the same exact number. But yeah, because they're equal. When I substitute that number in for X, it makes both sides equal. That's why there's an equal sign in the middle, right? If I had to try any of these other ones, let's try negative 26 over 9 instead. Let's say, all right, dude, negative 26 divided by 9, and I'm going to store that for X. All right, so now I'm going to type in each side of my equation. 7X minus 2 parenthesis X minus 9, and I get some number. But when I type in the other side, 4 minus 8 parenthesis X plus 2, well, they're not the same number because this was not our solution. It does not make both sides equal, right? So worst comes to worst. So look, we can definitely solve it. Distribute, combine like terms, isolate my variable, or I can just store these values for X and substitute them in and see which number makes both sides the same number. All right, no reason to miss that problem. All right, choose two factors to create an expression equivalent to 4x squared minus 81. Move the correct answer to each box. Each answer may be used more than once. Not all answers will be used. So I have a quadratic. I could factor it, or I could do lots of things, right? But hopefully we remember, man, there's no middle term. That's our special case, right? That means we have the same values, just different signs. Just one's positive, one's plus, and one's minus. All right, but these two should be the same, and then these two are the same. That's how I get there to be no middle term. All right, so I got to figure out, well, 4x squared, what number times itself equals 4x squared? Well, 2x. 2x times 2x is 4x squared. And what number times itself is 81? Well, 9. 2x plus 9 and 2x minus 9. Well, we have those. Those are two of our options. All right, 2x minus 9 and 2x plus 9. All right, some of you are like, yeah, I didn't remember that. Well, we could have factored it. I could do my Xbox. Yeah, all right. 4 times negative 81 is negative 324. And I want it to equal 0. Well, again, the only way for it to equal 0 is if these are both the same number, but one's positive, one's negative. So if they're the same number, well, that means I need to find the square root of 324. Well, the square root of 324 is 18, right? And we can always plug that in our calculator, but just trust me. So now, first in the first, 4x squared, last in the last, minus 81. So plus 18x and minus 18x. Well, our GCF of 4x squared minus 18x is 2x. This is plus. GCF of 1881 is 9. Side to side, GCF 2x. This is minus, so it's minus, and GCF is 9. 2x minus 9 and 2x plus 9. Well, yeah, that works. Well, that's what we got. Okay, so again, when there's no middle term, that's our special case. You'll notice these are both perfect squares. I can find the square root of 4, and I can find the square root of 81. All right, so when there's no middle term, I know they're the same value. One's positive, one's negative. So that means I should be able to find the square root of both sides. If I can remember that, that was not a hard problem. All right, if f of x equals 3x squared minus 7, what is the value of f of 4? Well, they are telling us what number to substitute in for x. They're saying, hey, find f of 4. So I just got to substitute 4 in for x. So 3 times 4 squared minus 7. Well, 4 squared is 16. 3 times 16 is 48. 48 minus 7 is 41. All that was really easy. All right. Or look, we got a calculator. We just practiced storing a number a couple problems ago. So if I do 4 and I store it for x, right, they're telling me substitute 4 in for x. So now I say, all right, 3x squared minus 7 is 41. This should be one of the easiest problems on the test. They tell us what number to plug in. We know how to plug in a number using our calculator. Then I just got to type in my equation just like it looks. 3x squared minus 7, 3x squared minus 7, 41. Man, that is a one. We got to slam dunk it. We got to know how to store that number. That's why we write it down in our brain dump. All right, an athlete ran at a constant speed for 12 seconds. The part of the linear function shown represents the distance the athlete ran in yards. Y is the function of time in seconds x. Blah, 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 blah. But it says, what is the domain of the function for this situation? Hopefully we know domain are our x values. Well, if I know domain is x, then right away, I know it's not C or D because domain are my x values. So now let's go back and look at our table. Our graph. Well, my lowest x value is where x is 0. My furthest point right is my greatest x value, and that's where x is 12. So all my x's are between 0 and 12, right? There's nothing past 12. It doesn't go to 14. Our graph goes to 14, but our data is from 0 to 12. It even said in the problem for 12 seconds. Know what I mean? Man, slam dunk. All right, last question on our test. What value best represents the y-intercept of the line? This is the last question on the test. This is probably the easiest question on the test. Y-intercept, that's just where it intercepts the y-axis. Is my y-axis at -2? I think this is our last question. So now, after going through this whole test, man, there are some hard questions on this test, but there were a lot of simple questions that we got to get right. All right. It's okay if we miss hard questions. We can't afford to miss easy questions. A lot of these questions are really easy. All right. If I got some common sense, remember our brain dump, and we know how to use our calculator. All right, guys. Hope these videos help.